Abbe number. In order to understand Abbe number, first we need to understand standard spectral lines. So what is a standard spectral lines? At each wavelength, when we look at the visual spectrum, which is roughly start from 400 to 750, each line, those lines that you can see, each of them is a representative of one kind of material. Some of the lines representative of one element at different wavelengths. Like for example, hydrogen has two lines here. I think sodium has a lot of lines, but each of them is very sharp, and we call each line based on uh, the element. For example, let's say at 365 the color is UV and the element is mercury. For mercury we have a lot of different lines, but some of them are very important. For example, the F line, which is for hydrogen, and the wavelength is 486.13. That's an important line for us. The other one is capital C line, which is for hydrogen again, but the wavelength is 656.27. So that's very close to red color. We can see the color is red. But for this capital F, the color is like blue. The other one that is important for us is D line, which is for helium. The color is yellow. The wavelength is 587.56. So we have different lines, and each of them have a name. So what we can do with those lines, those wavelengths, what is the Abbe number? So the Abbe number, and sometimes we call it V number, it has a definition, which is Nd minus 1 over Nf minus Nc. So as I mentioned before, Nd is the refractive index of the material at this wavelength, 587. So we have different materials. The refractive index is a function of wavelength because it's a dispersive material. Like in our eye, the materials that we have in our eye is pretty close to water, but all of them are dispersive. So you cannot represent the refractive index with only one number because we have a spectrum of light, different colors, from blue, which is 400, to red, which is about 700. So we have different wavelengths. So we cannot just say one number for the refractive index. So in Zmax, when you want to do the simulation, you need to provide two numbers. One of them is the refractive index, the other one is the Abbe number. Sometimes we call it V number. And this is the definition of V number. Nd minus 1, we have Nd, which is the refractive index at this wavelength. We have Nf, which is the refractive index at 486, blue, and we have Nc, which is the refractive index at 656, which is pretty close to red. So, what is the physical definition of this V number? When we look at this formula, on the nominator we have Nd minus 1, pretty constant number. Because Nd is a constant number, it changed for material to material, but minus 1. But on denominator, we have Nf, that 486 wavelengths, and this wavelength for Nc is very far from that number at 656. So we have the refractive index of at 486 and the refractive index at 656. So we have a big range. If the material is not dispersive, these two numbers, the refractive index should be pretty close to each other. So we have a very small value here. When you have a small value in denominator, you have a big value for the V number. So when the V number is higher, when the Abbe number is higher, it means that the material is not that dispersive. When the V number is higher, so when this V number is a big number, means the difference between the refractive indices for two different wavelengths, Nc and Nf, is pretty small. But now let's talk about a very dispersive material. When you have a very dispersive material, based on the definition, it means that the refractive index is a strong function of wavelength. So these two numbers should be big. So when these two numbers are big, then the V number is going to be a small. So we have a graph that is very famous graph that we have a 50 line. So when the V number or Abbe number is less than 50, which means that for material with higher dispersion, we call them flint glasses. And when the V number is higher than 50, which means that low dispersive, we call it crown glasses. So when we look at this graph, this side, which the V number is less than 50, all of them are flint glasses. And this side are crown glasses. So we should be very careful when we want to use the Abbe number for the eye, because most of the time people just report one number, but we should find the refractive index and Abbe number for the eye. So so we can say based on this definition, this material, the Abbe number is pretty small, has a higher dispersion. This material that has a high Abbe number, from the definition, we can say it has lower dispersion.